I don't like to smash machines. And there's been times that I've been on a setup and everything looks good, tools mounted, I'm getting ready to run, and all of a sudden the coolant flow doesn't come out, the tank had to be cleaned, or maybe some of these nozzles were clogged. So I'm gonna verify that before I start running the job. Hey team, this is Luke with Practical Machinist, and welcome back for another episode of the Lathe Lab. Today we're gonna be going over part 2 of how I process a job going from paperwork out to the shop to a complete part ready to ship. In part 1, we covered getting the job ready, getting gauges ready, materials, setting the bar feed, mounting tools, touching them off. So now we're gonna be going over what we do after that part. So let's hop right to it. So as you can see, this is the inside of our machine. We've got all our tools in there, laid out, mounted, touched off, ready to go. A couple of safety checks that I like to do beforehand is I want to make sure that my inserts are in good condition, tight, and that all my coolant is properly set for a production job. Now, that's possible because I don't have a lot of tools. I think I've got about 7 or 8 tools that have inserts. I'm gonna make sure that they're good and tight before we run. So I'm gonna index my turret around in the correct position. I'm just gonna give them a quick check, make sure that everything is in good shape. We're gonna go over our lower turret now. All right, everything looks good, nice and tight. I know my turning holders are because they were in there before. Now we're gonna check the water. Basically, we're gonna check our coolant flow so that once we're ready to run the program through, I don't say, oh shucks, now I have to stop the part that I'm in and verify that my coolant is well. Or sorry, verify that my coolant flow is good. So for instance, I'm hoping you can see through the door here, which yes we can, might be a little hard to see. I'm gonna bring that up in a moment. I'm gonna manually turn on my coolant. You can see, flow looks great. That's a boring bar I have in there. There we go. That coolant flow is top notch. I'm gonna jog around to my next tool, double check. That looks wonderful as well. Shut my coolant. I'm gonna go around to my cutoff. Right there, that's my cutoff in position. I wanna make sure, yep, if it's hitting the door and I can look inside that it's getting underneath that edge of the cutoff, wonderful. And that was in there before, so I know that it's good. Just wanna make sure. And there's been times that I've been on a setup and everything looks good, tools mounted, I'm getting ready to run. I dry run it through, program looks good, ready to make chips. And all of a sudden the coolant flow doesn't come out, the tank had to be cleaned, or maybe some of these nozzles were clogged or something like that. So I'm gonna verify that before I start running the job. And especially on tools here like my drills. These drills are gonna be drilling pretty deep. The job we're running is 60-61 aluminum. I would rather run 12-15 dry than 60-61. Not a big fan of running it dry. Have I done it on accident? Yes. Will I probably do it on accident again? Most definitely. So I'm gonna double check the coolant on those drills real quick, then we're gonna be off to the races. So the next thing that I'm gonna do, we double check the coolant, everything is good. I'm gonna get ready to run it through, but I'm gonna do what I call a dry run. It's what I call a dry run. Not dry run on the control, but a dry run itself. I'm gonna run the program through with no material, no coolant, so I can watch what it does. But there's one other safety check I like to do when I get here. And is this a little bit redundant? Maybe, maybe not. I don't like to smash machines. So what I like to do is to make sure that between my tool indexes, I'm in a safe position to index away. Now there's a lot of people out there that say, dude, that's unnecessary. You don't have to do that. Well, maybe I don't, but it'll take me a total of 2.5 minutes to go through and make sure I have a safe distance away before I index around for my next approach. So maybe I don't have to. Kind of been getting a little bit back and forth with a few people on my socials about CAM software. And I love CAM. We program in CAM all the time. But if you watch any of my stuff on the Practical Machinist channel or on my own, I'm a fan of hand programming. A simple, not a part like this, but a simple part, programming by hand, I'm all for it. And a lot of people say, no, 100% CAM, make sure the post is good. Sure, that works for a lot of shops. There's a lot of shops out there that don't have CAM, don't want CAM. It's a big expense, and I do not think it's necessary. So for that reason, I teach my students at school, the people I work with here, how to hand program. And I'm going to teach my sons that as well. I have 2 boys that work with me. I'm going to teach them the same thing. And there's going to be people that say, oh no, you should teach them CAM. Maybe they will learn CAM, but I'll die on this hill. You will be a better programmer and more valuable to your company, to this industry, if you can program by hand and CAM, which I can do. I can program in CAM, I can model, I can program by hand, I can edit programs on the fly if I need to. I'll do it all. And I am more valuable than someone that can just program in CAM, bottom line. So I'm gonna make sure that when I index through, I'm in a good, safe position. Remember, 2.5 minutes is all it's gonna take me to go through and make sure that the tool is moving away close enough or far enough away so I don't smash. And further than that, when I'm tooling up my job, I have my drills 1, 2, 3. First drill, second drill, third drill. So that when I go in and drill and I come back, I just have to index 1 tool position. Come back, index 1 instead of moving all the way around. Same with my OD tools. I have my rough and my finish right next to each other. Same with my mills on the sub. 1 right next to each other. I try to do that if possible. So let's verify that, then we're gonna run the program through. Everything's all safe. Everything looks all good. I'm getting ready to run it through. Program has been ran through on a dry run, no material, no coolant, dry run. Tools are in, coolant's good, all that stuff is set. We are ready to make a part. Now, when I'm getting ready to make a part, format I like to have my screen on. So of course my memory, upper and lower, so I'm grabbing both heads of the program, top turret, bottom turret, both paths at the same time. But now I'm also gonna go to my check screen. On my check screen, it's gonna have absolute position, distance to go. Now those are super critical to see that distance to go in case you're in a rapid move or a feed move, you know how far you have to go. It's gonna lay out what my spindle speeds are, what my feed rate is, and then my program up here. So the actual program that's gonna be run is here, all my other stuff are here. Then I can hit next, and on the next screen, it's gonna have all my active G codes. So if I'm in GO, G1, G2, G3, G97, G54, any of those codes where I'm at, and also what current tool is active. Tool 8, tool 10, so on and so forth. So when I'm running it through, I like to jog between my check screen and next to see what active codes, what I'm currently doing, where I'm gonna be going next. And I'm gonna be doing that with material. So as I'm running, I'm gonna shut my water. As my tool is approaching, as I get there to where I know I'm in a good position, I'm gonna turn the water back on and gauge the cut. Let's get into that. So it might be a little hard to see here, where now I'm gonna hit cycle start. I know my program is good, all my tools are in. I'm feeding out now. Now my coolant is on one tool just because I had a part in the sub for whatever reason. Now I'm gonna be going up to my main side. My water is off as my drill approaches, and I got my finger on the stop cycle button, and I know right here if anything happens at this time that I don't like, E-stop. Or sometimes you can just hit reset. But I tell people, feel free to hit the E-stop. It's not going to damage the machine. I mean, I guess if you repeatedly hit it over and over, but it's not really going to damage the machine. So I'm going to verify my approach is good on my drill. Once it's good, I'm going to turn my coolant on. I'm going to let it rip. I'm going to toggle between my check and my next screen while I'm watching my program and my distance to go. All right, my next tool indexed around. I'm going to shut my water on that drill. Make sure my approach is good. Oh, another thing, my rapids are at 100%. There's a button here to kick it down. I'm going to put my rapids down to 25%. If you want to be extra careful, there's an option to put it down to a 0%. Well, basically your rapids will move almost like it's in a slow, almost it's in a G1, a feed move. But I'm not going to do that. I'm approaching, rapiding G0 to my approach on my drill. I look good. I'm distance to go to my next screen. I am in G1 with a distance to go of 2.0768. Coolant on, let it rip. Oh yeah, that sounds beautiful. I pulled out, I'm rapiding in my next position. Now I'm gonna go to single block. Single block will run one line or one block at a time. All right, I'm at that position, my single block. My coolant was on. I'm gonna shut it off, make sure it looks good. I'm ready to rock and roll. And we're gonna do that so on and so forth. And you're gonna go between top turret, bottom turret, top turret, bottom turret for all the tools that are working on the main. All right, next thing, we're gonna make a part, we're gonna start checking it. So we are finishing up this cycle right now. One thing I didn't go over, but I'm gonna briefly cover right now is our pickoff position, our transfer point. We set all of our, touched up our tools, ran it through dry run, carefully ran everything through with coolant, with material to make a good part. Using single block, slow rapids, check screen, next screen, all the tools that the control has to facilitate that, safely running it through. Then what we do, we have to set our transfer point. At our transfer point, we can set it up on a set number by our sub-spindle is the A-axis. We can determine that A0 or what is the A position based upon the machine zero, but I've kind of burned myself in the past from doing that, and granted, that's operator error. I've made a mistake doing that, it's operator error. So what I like to do is bring both turrets above the material, out of the way, the same position they would go in the program, and then I manually jog up, I set my approach for my transfer, and then I set my actual transfer itself. Then we transfer. I have a part in the sub right now from the transfer. So that what we do now in this case is I run only my sub-spindle tools. I don't need to rerun the main. I don't want to, blah, blah, blah. I'm gonna run the sub. Touch off, teach the tools on X and Z on the sub side, run those through, get my part out, begin inspection. At this point, we are done with the machine side of things until we're ready to go full production. Now that we have our part from our machine, as you can see, nice deep hole bore, we begin our, what I like to call our preliminary inspection. I'm gonna go through just a few basics of the dimensions. Bore diameter with our sun gauge, make sure we like it. We have a deep groove down there. I'm gonna verify that. We set our min, max tolerance, and normally we'll either set that with a micrometer or a standard. And we check our go and no go with our gauges. These gauges here are customer supplied. It's a customer supplied go and no go. That go gauge actually feels pretty tight as we get down to the bottom. We want to ensure that that sits nice and flat. per customer requirements. And we also have these homemade gauges to check the functionality of that bore. So our sun-in, the reason what I mean by that is our sun-in gauge will tell us if it's in tolerance, but the sun-in gauge is mechanical and it has to be set per part. What if it's set wrong? That's why we have a functional gauge. So I'm going to continue going through this. I'm going to check our depths, check our little pipe thread. Let's do that right now. And we like to run that within flush to plus or minus a half a turn, or I'm sorry, flush to plus a half a turn to the flat. On these NPT gauges here, there's a little flat. That flat is how you reference whether or not that's deep enough, because the NPT is as the name implied, is a taper thread. So you can't just check a go and no go, it's on a taper. So it has an end point it has to stop to. Check our diameters, check all of our lengths, visual inspect. Everything on there is looking pretty darn good. We got these cool milled flats. Little chamfer, looking great. There's a couple tight surface finishes that we have to check inside. We'll do that with a profilometer, but this is nature's profilometer right here. Just kidding. What we do use though, that's a good on the fly profilometer, is the ball end of a hex key. This one's a little large. There's a little trade secret my old man showed me. On a hex key that has a ball end, you run that ball end over it. It'll give you a good idea with some good industry experience what your surface finish is. So let's say for the sake of argument, our in-process inspection is done. Once we're done with that preliminary inspection, I'll usually use a pencil and a print, write down all my critical features. It's a program we've ran before, so I know all my geometry is good, my angles and radii, stuff like that. As long as I use the tool nose radius that's specified on my setup sheet that we saw in part 1, and I use that same program that we dumped in on part 1, my geometry is good. It's just a matter of my lengths, and that's going to be determined by how I touch off my tool, how I teach it in both X and Z. So I'm going to do the preliminary checking on what we call here our critical features. Your lengths, your threads, your bore diameters, your outside diameters, your visual inspection. Once that's good, we're going to go one step further. I'm not going to bring you through that, but we have these quality records we fill out that has every feature on the print. Some people would know it as an FAI. We call it a first piece approval. Me, the setup person on the machine, checks to make sure it's good. I fill out the quality record, but then I also have to have a qualified person fill it out. Most of the time, that would be my cousin. His name is Andy, a wonderful human being, very good at his job. He will go through and inspect it for me. Most of the time, I'm going to run in the meanwhile because I trust my judgment. But the process normally would be, we would hold off on our production until that first piece approval is done. After that, we're gonna hit edit, program, reset our machine. I am going to hit cycle start, and we are off to the races. We will be running full production. That light, see that? That green light, that's what we want. So this is kind of what I would call the boring part. I love setup, I love programming, I love making chips, getting those spindles turning. But after that part, I pass it off to an operator. And an operator then is gonna operate that machine and maintain part quality, machine uptime or efficiency to make sure that that green light stays green as long as possible throughout their shift. Meaning we have to keep the bar feed loaded with bars. We have to ensure our coolant tank is loaded with coolant. and that our parts are coming out our part conveyor. While that's happening, they're ensuring quality. And the people that we have here are quite qualified. They would know that if you had plus or minus 30 thousandths bore or a plus or minus 5/10 bore, which one are they going to inspect more frequently? The plus or minus 5/10. The tighter tolerances are what we're going to check most frequently. Sometimes 100% of them. And that concludes part 2 of our process of how do we go from paperwork brought out to the shop to part complete, ready to ship out the door. I hope you enjoy this little 2-part series. I didn't want to cram it all into one video. I thought it might have got a little bit too long. It maybe would have crept up to about a half an hour or so. And I know it's not everyone's bag, but a lot of people out there, like myself, love processes. I love establishing processes. I love process improvement. So I hope that you like this video. I hope you're able to learn something and that it entertained you well. This is Luke with Practical Machinist, signing out for another episode of the Lathe Lab. Thank you again for watching, and we'll see you next time.